Okay, so we just learned about tectonic plates, and that when two tectonic plates are next to each other, it creates a border. And that border is where we see most of the earthquake and volcanic activity. So this picture right here is showing what we call the ring of fire. Okay, so this plate right here, so this is going to be the Pacific Ocean. So you've got the west coast of North America, and you've got the Japanese chain of islands right here. So you've got Japan. We have lots of smaller Pacific Ocean countries, and this is where we're going to see the majority of all geologic activity on the planet in the Ring of Fire. So we're going to have most of our volcanic and earthquake activity at this location. Now, I told you that where you have two tectonic plates interacting is where we see the activity. Yes, but most of the activity in the world is going to be at the Ring of Fire. So, the majority of volcanic activity is at plate boundaries. Okay, so if you look at the map, guys, here we see all these red dots are volcanoes. So most of them in the world are in what we call the Ring of Fire. Okay, it occurs at what we call subduction zones. And I'm going to explain to you what that is in just a second. Now, if I were to ask you, if I said, hey, look at this map. Do 100% of volcanoes occur at plate boundaries? You looked at this map. Would you tell me yes or no? You would tell me no, because look at this. Look at this. Are those at a plate boundary? No, they're in the middle of a plate. Now this right here, this is Hawaii. Now we know that Hawaii are volcanic islands, okay? But this is in the middle of a plate, so there are exceptions to that rule. So if you have volcanic activity in the middle of a plate, these are called hot spots, okay? Hot spots. This is where you have a volcano in the middle of a tectonic plate. So it is possible. It's not common, but it does happen. For example, the Hawaiian Islands are hot spot, okay? So let's look at how these tectonic plates can actually interact with each other. They can interact in three different ways. Okay, so right here, let me go back up a little bit. Right here, these are the three types of plate boundaries. Okay, so the first type we have is divergent. Divergent. So look at the arrows. What are these plates doing? They are moving apart. Okay, so what kind of geologic activity do we see at divergent plates? Okay, so right here we see what we call seafloor spreading. Okay, which creates what we call rift valleys. All right. We see volcanoes, because look, the magma is going up to the surface. And we do see some earthquakes from this type of boundary. Okay, so that is divergent. All right, the next one we have is convergent. So look at the arrows. These are moving together. Okay, now I just told you guys about subduction zones. Okay, subduction zones are this right here. This is subduction. So if you look, this plate, they're moving together, this plate is slipping underneath the other one. That is called subduction. Okay, so this type of boundary, the convergence that are coming together, okay, this is where we're going to see the creation of mountains. Okay, mountains, we also see what are called island arcs, and they're literally islands that are in the shape of an arc. Okay. Obviously earthquakes. And we do see some volcanic activity at these as well, as we just talked about at the Ring of Fire. Okay, now the last one we have is transform. So if you look at the arrows, these are sliding past one another. So they're literally going like this. Okay, this is where we see just simply earthquakes. Okay, now with a transform fault boundary, so fault right here is going to be that key word. This right here, so this actual line between these two, that is what the fault is. So that's called a fault line. And you guys probably have heard the term fault line before, typically in reference with the very well-known fault line that runs through California, the San Andreas Fault. Yes, there was a movie that The Rock was in about it, but that is an actual fault line. Okay, so what a fault is a fracture between two rocks. Okay, now you can actually see the fault line in California, the San Andreas Fault line. So right here, this is a picture of the fault line. So we have the Pacific plate rubbing up against the North American plate. So they're sliding past each other. And when that happens, here we have an earthquake. Okay, so the fault line basically runs almost the entire length of California. This is the most active fault line in the United States. It's basically earthquakes every day. Now, most of them are small. They're not even noticeable, but they can be quite extreme. So the most active fault line in the U.S. Okay, so this is when earthquakes happen. So earthquakes occur when stress overcomes a locked fault. Okay, it releases stored energy. So what this means, guys, is you have a locked fault. You have these two rocks that aren't moving at all, and a significant amount of stress has built up underneath them. There's enough energy to cause them to move. Okay, so that is an earthquake. And I think it's really important for you guys to understand how earthquakes are measured. So earthquakes are measured on what we call the Richter Scale. Okay, the Richter Scale is logarithmic, meaning so that when you say it's an earthquake magnitude 5, what does that mean? How strong is that? Okay, so the way that we look at this is, so I'm just going to make a number line. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so each earthquake is measured on this Richter scale. Okay, so an earthquake 7 compared to an earthquake 3. We know that a 7 is going to obviously be bigger, but how much bigger is it? So let's say we have 7 and 3. Okay, so logarithmic scale means we're not simply counting by ones. We're counting by tens. So 1, 2, 3, 4. So that gives us 10 to the fourth. So what is 10 to the fourth? 10,000. So an earthquake size 7 is 10,000 times stronger than an earthquake 3. That's why this scale is so significant, because it measures the actual magnitude of the energy that's released. And we know that the higher magnitude is obviously going to be more damaging. So I'm going to be posting some videos for you guys to watch of the earthquake that hit Japan in 2012. And it was the strongest earthquake recorded ever. And it caused a lot of damage. I know you guys may be too young to remember when some of this happened, but it was quite significant. It was so strong that it actually caused the Earth's axis to shift a little bit. It caused Japan, the actual island of Japan, to move. It was a massive earthquake, and then, you know, we had the after effects of the tsunamis and the nuclear disaster. So I really hope that you guys learned a lot from this, and you'll enjoy some of the videos that I post.